Okay, hello and welcome back. In this video, we're covering section 5.4 on scientific notation. So scientific notation is a way of being able to easily write and work with really small or really large numbers. So far, we've been working with numbers that are pretty close to zero. Um, so we work a lot with like whole numbers, maybe some slightly large numbers. We might have worked with a few numbers that are at like three digits or something like that. But a lot of times in applied math problems, so you'll see these in the sciences, so maybe in classes like chemistry or astronomy or physics, or even in the businesses, you might see some really large or really small numbers. So like 137 million. That's even still relatively a small number compared to something we could produce. Um, so scientific notation is a way of sort of writing this in a more condensed form. This could be expressed as 1.37 times 10 to the 8. So we'll explore how to produce these kind of abbreviated expressions for both really large and really small numbers. Um, so we'll start in just reviewing some properties of exponents. That's where a lot of this will come from. Um, we'll define more specifically scientific notation, then we'll practice writing some numbers in scientific notation and performing some operations. And that's where a lot of the power will come from in terms of putting it into this form. We'll be able to do some multiplication and division a lot easier than working with the larger numbers. So first, let's just review working with multiplying by some power of 10. And we did this a bit in some previous sections when we were trying to deal with some decimals in order to express a number without a decimal. If we had it in an equation, we multiplied by some power of 10 in order to move the decimal. So we'll see that same kind of action here. So just to review, if we're multiplying by some positive power of 10, the decimal point moves to the right. And if we multiply by some negative power of 10, the decimal point would move to the left. So let's see a few specific examples. So in example 1, in part A, we have 3.4 times 10 just to the first power. So 3.4 times 10 to the first power. So the power is positive. So that means we're going to move the decimal one place to the right. So I can imagine picking up that decimal point, moving it one place to the right, and that will be our new location. So 3.4 times 10 to the first power will give us 34.0. We can just write 34. Part B, we have 0.0857 times 10 to the third. Notice they're using two different symbols for multiplication. One is the x and then the other is this little dot. Just two different ways of expressing multiplication. We tend to not use the x as much, especially once we start introducing variables, and x is a common variable, so to avoid some confusion. And that can have some other mathematical meanings as well. So a lot of times we see this dot notation. So 0.0857 times 10 to the third. So I'll imagine picking up that decimal point and moving it to the right 3 spaces, and that will be its new location. So I can say this should be equal to 85.7. And then let's use some negative exponents. So from example 2, in part A, we have 41 times 10 to the minus 2 power. So this is going to make the decimal move to the left 2 places. So there's no decimal present, but we can view this as 41.0. There's always like a 0.0 if we have a whole number. So I'm going to take that decimal, move it left 2 places. That will be its new position. So this should be equal to 0.41. And then for part B, we have 367 times 10 to the minus 4. So I'm going to write this again as like 367.0. And so if I'm imagining taking this decimal point, I'm going to move it to the left 4 spaces, because we have the minus 4 power. So I'll pick up the decimal. So that'll be 1, 2, 3. And notice if I move it to the 4th position, I'm sort of beyond our first number. Anytime you get an empty space like this, there'll be a 0 in that empty space. So that means this would be written as 0.0367 as our result. So we moved this decimal place 4 spaces to the left. It produces this extra like little pocket that gets filled with a 0. And that would be the same if we were moving it to the right and we got some extra numbers. So for example, if we had like 3.6 times 10 to the 4th power, I would move it to the right 4 spaces and I get 3 places that get filled in with zeros. So that's true going to the left or to the right. If you get some extra places, they get filled in with zeros. So with that in mind, these 2 rules, let's work more specifically with scientific notation. So it has a specific definition. So they describe a number being in scientific notation if it's written in the form some number a times 10 to some power, where they say that number a is in between 1 and 10, and it's an integer. Meaning whatever we have times 10 to some power needs to look something like a single number, maybe with some decimal places. But it's this number that they're saying is in between 1 and 10. So meaning if a number was like 13.2 times 10 to the third, we would say it's not technically in scientific notation because this number before the decimal is greater than 10. What it would really be is 1.32 times 10 to the fourth. So the number in front of the decimal is between 1 and 10. Let's see a few examples. So all of these look like they're in scientific notation. 5.923 times 10 to the fourth, 7.4 times 10 to the minus third, 1.8875 times 10 to the third. So they're all in scientific notation, and it wants us to rewrite without exponents, meaning to take it out of scientific notation. So we have for part A, 5.923 times 10 to the fourth. So I'm going to take the 5.923, I'm multiplying by a positive power of 10, so it's going to take the decimal, move it to the right 4 spaces. 1, 2, 3, 4. I get this extra place that will be filled in with a 0. So I can say this should be equal to 59,230. For part B, we have 7.4 times 10 to the minus third. So I'll take that 7.4, I'm multiplying by a negative exponent, so that means this decimal place will move to the left 3 places. So 1, 2, 3. I get 2 extra places to fill in with zeros. So I can say this will be equal to 0.0074. And then for part C, I have 1.8875 times 10 to the third. So I will take the 1.8875 multiplying by a positive power of 10 and to the third power. So it will move to the right 3 places. So our number should be 1887.5. So this is taking a number that's already in scientific notation and basically expanding it out. But oftentimes we're going the other way. We have some large number or some really strong number, some really small number, that we want to put into scientific notation. So let's look at this first example. It says the distance from the sun to the earth, from the earth to the sun, is approximately 150 million kilometers. It's a really long distance. So we want to put this into scientific notation. I can already see where I would want the decimal to be. We wouldn't put it as 15 times 10 to some power because remember the number in front of the decimal needs to be between 1 and 10 and less than 10. So basically between 1 and 9, including 9. So that means I want the decimal to end up in that position between the 1 and the 5. So I want to write it as 1.5 times 10 to some number, some power. And the power is the number of decimal places that need to be moved. So if I just count from this starting point, 1, 2, 3, 4, 5, 6, 7, 8, that's 8 positions. So that means this should be 1.5 times 10 to the 8. And it's a little tricky because from this perspective, we're moving the decimal place to the left, but we're kind of going in reverse here. Imagine starting at this point, and then if we were to expand it, we want this number to be bigger. Like we would want to take this decimal and move it to the right a certain number of spaces. So from that perspective, it makes sense that this should be a positive 8. If it's a negative exponent, that means we would be making a number smaller. So we'll see that in our second example. So that means we can express 150 million as 1.5 times 10 to the 8 pi. Part B says a single rhinovirus. So this is like a very small virus particle, molecule, measures 0.00002 millimeters across. It's a very small distance. So for this to be in scientific notation, I'm imagining the decimal place should be right after this 2, 2.0 times 10 to some power. And the power will be the number of spaces we need to move. So 1, 2, 3, 4. That's 5 spaces. And here, since we're starting at 2 and we want to make this smaller, that means this needs to be a negative exponent times 10 to the minus 5. Because from this perspective, we would have the 2.0 and then the minus 5 power would move it 5 spaces to the left, producing this small decimal value. Oops. So in converting to scientific notation, I identify where the decimal should be, and then count how many places need to be moved. And then you can decide if it's positive or negative. If you're starting with some really large number, it's going to most likely be some positive exponent. And if you're starting with some really small number, it will most likely be some negative exponent. And you can always check yourself by going backwards. If you were to take it and convert it back to a number not in scientific notation, do you get your original result back? Okay, so we can perform operations with numbers in scientific notation, and that actually makes the math um, a bit easier if we're working with really small or large numbers. So what we generally need to do is follow the rules of exponents. Which we covered in some of our previous sections. So in this example, we have 3 times 10 to the third power divided by 4 times 10 to the fifth power. So we can express this. This is just multiplication. Maybe I can write it like this: 3 times 10 to the third power over 4 times 10 to the fifth power. Just same expression, just notating it a little bit differently. So that means we can view this as 3 over 4 times 10 to the third over 10 to the fifth. Everything's being multiplied, so we can split this into a multiplication of 2 fractions. And then this right fraction, we can simplify using rules of exponents. So let's remember, if we have something like a to some power n divided by a to some power m, they have the same base. If you remember the rule for this was the quotient rule for exponents. This will result in a to the power of n minus m, meaning we would subtract these exponents. So that means we can express this, the 3 over 4, that's 0.75, 3/4. And then 10 to the third over 10 to the fifth, we can write as 10 to the 3 minus 5 power. So performing that subtraction, that means we have 0.75 times 10 to the minus 2. But we're not quite in scientific notation yet because we would really want the decimal to be between the 7 and the 5. We want the number in front of the decimal to be between 1 and 10. So if I scoot the decimal place over one more place, that means I would need to add another number here, 7.5 times 10 to the minus 3. And then if we expand that out, this would be 0.0075. So we could have these, depending on what the question is asking, if it wants it in scientific notation, we can do that first, this first way of writing. Or if it wanted the expanded out version, we can have our second solution. We don't have a specific example, but if these were multiplied together instead of divided, so if we had something like 3 times 10 to the third times 4 times 10 to the fifth, we would still just follow rules of exponents. Use my dot notation here. So that means, to write it in another way, 3 times 10 to the third times 4 times 10 to the fifth. And we can rearrange this a little bit. This would be 3 times 4 times 10 to the third times 10 to the fifth. So the 3 and the 4 will multiply. So that would give us 12 times 10 to the third times 10 to the fifth. And then remember, if we had a multiplication, so a to the power n times a to the power m, a multiplication of two bases that are the same and two different exponents, we end up adding the exponents together, n plus m. So that means this can be written as 12 times 10 to the power of 3 plus 5, which would be 12 times 10 to the power of 8. So that would be if we had a multiplication of two numbers in scientific notation. So if that's the case, then we multiply the numbers in front and then add the exponents. In our actual example here, we had a division of two numbers in scientific notation. So we divided the numbers in front. We did 3 divided by 4, and then subtracted the exponents. So another way of trying to remember the process here. All right, that's it for this section. So we practice multiplying numbers by power of 10. Wrote in some forms from scientific notation into like a regular expression, but then also went the other way, put a number into scientific notation, and then did some multiplication and division with numbers in scientific notation. Okay, that'll be it for this video, and I'll see you next time.